Welcome to This Explainer. Today we're unpacking a really incredible cosmic detective story. We're looking at a brand new discovery in modern astronomy, a giant exoplanet named Beta Pictoris d. And what's wild here is how the James Webb Space Telescope managed to spot this thing when it was, for all intents and purposes, completely invisible.
Okay, let's dive right into this. Seriously, how do you find a massive planet when it's completely swallowed up by a blinding storm of cosmic dust? To figure that out, we have to rethink how we search the stars. And as you'll see, a pretty lucky accident led us to a totally groundbreaking new way of seeing the universe.
First, let's set our cosmic crime scene. We're traveling exactly 63 light-years away from Earth to the Beta Pictoris system. Now, I know 63 light-years sounds like a lot, but in galactic terms, that's literally right next door. It makes this system an incredibly rich, accessible target for figuring out what's happening in our stellar neighborhood.
And the system itself is pretty young, only about 23 million years old. Because it's just a baby in cosmic time, it served as this amazing, well-studied laboratory for scientists trying to piece together exactly how planetary systems form and evolve. It's chaotic, it's dusty, and it's absolutely packed with the building blocks of planets. And with this new discovery, Beta Pictoris just joined a very exclusive club. It's now only the second known planetary system to contain at least 3 directly imaged giant planets. Before this, we only knew about Beta Pictoris b and c. Adding planet D to the mix makes this an incredibly complex, crowded little system.
But here is the crazy part. Finding this third giant, it was a complete accident. Like lead author Aidan Gibbs pointed out, researchers were actually just using Webb's near-infrared spectrograph to study the atmosphere of an already known planet, Beta Pictoris b. They weren't hunting for anything new at all. But then, boom, this unexpected, game-changing clue just appeared right there in the data.
Now, what's really interesting about this discovery is exactly how Beta Pictoris d actually appears to us. It didn't show up as a standard photograph or a bright little dot of light. See, Beta Pictoris has one of the brightest debris disks we know of, and all that dust scatters the starlight, which completely blinds conventional imaging. So instead, the planet appeared as a chemical signature. By using spectroscopy, the researchers could effectively filter out all that blinding dust and see the distinct fingerprint of a planetary atmosphere hiding deep inside it.
Let's unpack that for a second. Spectroscopy is an analytical technique used to isolate and identify unique molecular signatures. Think of it like dusting a crime scene for invisible fingerprints. Scientists analyze the light passing through or emitting from an object to look for specific patterns, absorption lines, that tell them exactly what chemicals are present.
So what were those fingerprints? Well, the telltale signal that first gave the planet away was this really distinctive pattern of carbon monoxide absorption lines spotted by Webb's near-infrared spectrograph. And then, follow-up observations using Webb's mid-infrared instrument found even more evidence: water vapor and methane. These are absolute, undeniable signs that a giant planet's atmosphere was lurking right there in the dust, totally unseen by traditional cameras.
Section 1. The Hidden Giant, Beta Pictoris d.
Okay, so Beta Pictoris d is a massive world. We're talking at least twice the mass of Jupiter. But surprisingly, even though it's an absolute behemoth, it's actually the smallest of the 3 known planets in the system. It orbits its star at a distance of about 30 astronomical units, which for perspective is very similar to where Neptune sits in our own solar system. That gives it the widest orbit of the 3, putting it just inside the inner edge of that massive debris disk. Now, when you find a signal this surprising, you really have to be careful. Initially, the researchers had to take a step back and ask, wait, is this actually a planet, or is it just some background star or a brown dwarf passing behind the system? Bright features in these images can so often just be instrumental quirks or structures within the debris disk itself. So they needed solid, indisputable proof.
So the crucial point is how they used that spectroscopic data to confirm the planet's identity. The data didn't just give them the chemistry, it actually allowed them to determine the object's precise motion. The speed of the object, its exact position, and its alignment with the debris disk, it all lined up perfectly. This effectively eliminated any possibility of a background star and proved, beyond a shadow of a doubt, that Beta Pictoris d was indeed an orbiting exoplanet.
And the broader scientific community didn't just take their word for it either. A completely separate imaging study led by researchers from the University of Edinburgh independently confirmed the existence of Beta Pictoris d. By using simultaneous imaging from the European Southern Observatory's Very Large Telescope and Webb's near-infrared camera, they validated this incredible spectroscopic discovery.
Section 2.
A new era of discovery.
Let's see how this builds a completely new blueprint for finding exoplanets. Step 1. We can now specifically target those incredibly dusty environments where traditional imaging totally fails us. Step 2. We use moderate resolution spectroscopy to filter out the blinding debris, searching for chemical signatures instead of visual light. And Step 3. This technique lets scientists instantly start analyzing the planet's temperature, chemistry, and motion, right from the very first observation. It is a massive, massive leap forward in both efficiency and precision.
Which brings us to our final thought. For years, Beta Pictoris d was sitting right in front of us. It was obscured by this bright disk of debris, only revealing itself through a barcode of chemical light. So if this one system hid a giant planet so well, you have to wonder, how many more hidden giants are waiting in the dust of other solar systems? As the James Webb Space Telescope continues its mission, one thing is absolutely certain. The universe is about to get a lot more crowded. Thanks for joining me for this explainer.